Every single second, our world generates an overwhelming flood of raw information. Sensors track temperatures, cameras record intersections, and spreadsheets log exam scores in a relentless, unstructured stream. At its most basic level, we call these isolated facts and figures data. But on their own, without any context or structure, these numbers and observations offer zero insight. In fact, they usually cause absolute paralysis. This massive collage of screens, Polaroids, and graphics shows exactly what paralysis looks like. Hundreds of unlabeled files dumped into one space create an impenetrable wall of digital noise. You cannot find what you need, let alone learn from it. Yet the tools we rely on every day somehow cut right through the chaos. Map applications take millions of disorganized location pings and instantly recommend the fastest route home. Weather apps pull disjointed satellite readings and accurately predict tomorrow's rain. The difference between the messy desktop and the flawless prediction is structure. Raw observation without a strict processing pipeline is noise, not knowledge. The first step to taming that noise is isolating the raw material and identifying its exact data type. You cannot process information until you know exactly what kind of material you are holding. At the foundation are simple building blocks. Numerical data consists of counts and measurements. Text data includes names and descriptions. But the pipeline handles heavier loads. Images, sound, and video are complex inputs requiring entirely different processing rules. Gathering these different types requires specific tools. We collect text and numbers through human-led surveys and manual records, while image and sound data are pulled in automatically through instruments like thermometers, security cameras, or web scrapers. Sorting these inputs by their inherent properties is a strict requirement. If the system does not know whether it is looking at a word, a number, or a pixel, it cannot pass that information further down the line. Once the data is inside the system, it hits a massive vulnerability bottleneck: organization. Without a deliberate system to track files, they face accidental loss, suffer unwanted disclosure, or simply decay into useless clutter. This graphic lays out 4 strict pillars of data survival. First, raw files are classified from a desktop into a structured hierarchy, like a school folder. Finally, files receive descriptive names, like solarsystemdiagram.pdf, and are locked into encrypted cloud storage. Deliberate care and rigid structuring are the only defense mechanisms we have against information corruption. Securing data in the dark is a necessity, but it is not the final goal. Once it is safely organized, it has to be rendered into a format that the human eye can actually read and evaluate. This animation shows how we force raw categories into rigid rows and columns. Tables allow us to pinpoint specific values with numerical precision. Alternatively, bar charts sacrifice exact numerical precision for immediate visual comparison, letting you instantly see which category is larger. This visual representation serves as a vital translation bridge connecting cold machine storage with human comprehension. That comprehension sets up the final, highest-stakes objective of the entire pipeline: pattern recognition. By sorting and filtering our visual representations, we expose hidden similarities. Connections that were completely invisible back in the raw, messy deluge of information are now mathematically obvious. This scatterplot shows how statistical analysis tracks connections. Mapping consequences across massive datasets reveals how changes in one area affect everything else. To scale up, machine learning models use this exact pipeline, processing information and spotting patterns at speeds far beyond human capability. This macro-level processing is the hidden architecture behind the apps you use every day. It is how a music platform analyzes your listening history and recommends the exact song you want to hear before you even type a search. Left alone, raw facts and figures are merely a historical record, but when processed through a strict, disciplined pipeline, data sheds its chaotic noise and becomes the core engine driving our future decisions.